All right, this is section 1.5, linear and compound inequalities. So we start off by looking at these properties of inequalities, which are very similar to our properties of equations. Everything that you would do to an equation, you're going to do to an inequality with one exception. Okay, so number one says that if x is less than a, then I can rewrite that as a is greater than x. Now notice the direction of the inequality. And if you flip this around, you want to make sure that the direction of the inequality is still opening towards whatever, variable or value that it is. So the same holds if this were x is greater than a, then this would be that a is less than x. Okay, so your inequalities need to open in the same direction. Okay, now number two just says if you add a number to one side of the inequality, you have to add it to the other. Number three says if you subtract the number from one side, you subtract it from the other. And then here's where things start to get a little bit different. You can divide an inequality by a positive number and be okay. So you can multiply or divide. So if you multiply by a positive number on one side, you multiply by the positive number on the other. If you divide by a positive on one side, then you divide it on the other. If the value that you either multiply or divide, if it is negative, then you have to flip the direction of the inequality. And I want to point this out. Notice it said that if C is positive and A is less than B, then A times C is less than B times C. And if A is divided by C, again, this is when C is positive, that A over C is less than B over C. Notice how in both cases, our inequality stayed the same. Okay. Now here, if C is negative and A is less than B, now remember, C is negative, but look at what happens to your inequality. So the step in which you multiply or you divide by a negative, that's when you have to flip the inequality. Okay, now just to do something really simple, let me emphasize this real quick. If I have, let's say that I have 2x is greater than 4. Then I would divide both sides by 2. And this would just give me that x is greater than 2. So nothing changed. Nothing was different, okay? But here, if I have 2x is greater than 4, sorry, negative 2x is greater than 4, then I do not do this. Do not divide both sides by a negative 2 because you are changing you're changing the problem. Okay, so what needs to happen is in this step, when you divide by the negative 2, that is when you flip the inequality. And so now this is just going to give you x is less than negative 2. Now I'm going to prove my point. So this is what we started with up here. Okay, so if x is greater than 2, pick a value. So let's just say x is 5. 2 times 5 is 10. 10 is greater than 4. That is true. Okay. Now, at this step, again, x is 5. So 2 times 5 is 10. 10 divided by 2 is 5. 4 divided by 2 is 2. 5 is greater than 4. That's true. Now here, x is less than -2. So let's pick a value less than -2. So let's just say -3. So -2 times -3 is a +6, and 6 is greater than 4. Now, when we plug this in here, -2 times -3 is a 6, divided by -2 is -3. 4 divided by -2 is -2. -3 is less than -2. However, notice that if I were to do this, if I didn't change my inequality, and I said, okay, I just have to divide both sides by -2, and then you flipped it down here. Now, again, we're going to say that x is still -3. Watch. -2 times -3 is a +6 divided by -2. That's a -3. 4 divided by -2 is a -2. Now, this statement is not true. -3 is not greater than -2. Okay? So that's why when you divide by the negative, that is when you have to flip this inequality. All right? So I just needed to point that out. So be very careful when you do this, okay? And then the statements are also true expressed with the symbols. All of these symbols. So we can replace all of these symbols with this. Okay, everything holds. Okay, so we're going to solve all of this like normal, then leave our answer in set notation and interval notation. All right, so for number 1, I'm not going to show every step, okay, but I am going to explain as we go. So number 1, I need to distribute. So this is going to be 3x plus 12 is less than 5x minus 8. Okay, now for an equation, you would probably move your variable to keep it positive. So I'm going to go ahead and subtract 3x from both sides. So that gives me 12 is greater than 2x minus 8. And then I'm going to add 8 to both sides. So that's 20 is greater than 2x. I'm going to divide both sides by 2. I'm okay as long as it's positive. I do not change my inequality. So I get 10. Now, sometimes this is a little tricky to understand. But if you remember back here at number 1, if this is what we have, I can rewrite it the other way. Okay? So notice that my inequality is opening towards the 10. So I'm going to flip this around. I'm going to put the x, and here's my 10. And my inequality, since it's opening towards the 10, then I'm just going to do that. Now, I flip the inequality not because I multiplied by a negative, but just because I rewrote it backwards so that I could have my my variable first. Okay, now we need to answer this in set notation and interval notation. And I always think it's easier to graph it so that you can see what's going on. So if x is less than 10, that's a parenthesis that opens towards the left. Okay, now my set notation is a set of all x such that, and then all I'm going to do is take this statement that x is less than 10. That's how we do our set notation. Now, interval notation I get from the graph. So that's from -infinity up to 10, and they both have parentheses. And this is my solution. Okay. All right. Now, let's look at number 2. So this one looks a little bit more involved, but that's okay. So we're going to distribute. So we get 8x minus 16 minus 3x plus 5. Now, do not start moving things around. Clean up each side, just like you would with an equation. So 8x minus 3x, that's 5x. Minus 16 plus 5 is minus 11. Okay, now We're going to move the 11 to the other side. So I'm going to add 11 to both sides. So that's 27 is less than 5x, less than or equal to 5x. I divide both sides by 5. Since it's a positive 5, this is going to give me, I don't change the direction. I don't flip the inequality. Okay, at least not now. Now, I don't like the way this is written because my variable is not written first. So now I'm going to rewrite this where I put the variable first. Now notice that your inequality is opening towards the x. So x is greater than or equal to 27/5. All right, so I'm going to put this on a number line. I'm going to call it 27/5. And it says that x is greater than or equal to. So that's a bracket, and I shade everything to the right. Okay, now my set notation, let me just squeeze this up here. It's the set of all x such that, and then all I'm going to do is take this and rewrite it, that x is greater than or equal to 27/5. And my interval notation I get from my graph. So 27/5 with a bracket, and it opens towards negative, it goes towards negative, I'm sorry, it goes towards positive infinity. Okay. All right. Now, this one has decimals, and you can either clear the decimals if you want, but since you have a calculator, I would just deal with it. Okay. But if you want to clear the decimals, it might be a little bit easier. Let's go ahead and do that. So let's multiply by, since I have one decimal place, that means 1 0. So I'm going to multiply by 10. All right. So when I multiply this whole thing by 10, it's going to impact that value and that value only. So this is going to give us 3 times x minus 4 is less than 5 times x minus 6. And then we can solve. So 3x minus 12 is less than 5x minus 30. Okay, I'm going to solve this one differently. Instead of moving my variable to the right to keep it positive, I'm going to move my variable to the left. All right, so I am going to show my step on this one because this one's going to be different. Now, the reason why I'm doing this is because I want you to see how number 5 turns out. Okay, all right. So we have a negative 2x minus 12 is less than negative 30. I add 12 to both sides. So that's going to give me a negative 18. Now, our natural, because of we're used to dealing with an equation. So when we had an equation at this step, we would just say divide both sides by negative 2. I cannot do that here. So here's what happens. Since I am going to divide both sides by a negative 2, I flip. That's when I flip my inequality. You don't do it up here. Don't put divided by negative 2, divided by negative 2. Okay, because that would not be a mathematical correct answer. Okay, so this is gone. So now we have that x is greater than 9. All right, so our set notation is the set of all x such that x is greater than 9. And then interval notation, well, if I put the 9 on a number line, it's a parenthesis that opens towards the right. So it's going towards positive infinity. So it's 9 with a parenthesis to infinity with a parenthesis. And that's my answer. Okay. Now, if you did it the other way, where you moved the 3x to the other side, then you would just have to rewrite like we did here and here. So that's totally up to you. All right. But sometimes you're going to be forced to having to divide by a negative. And so when you do, this step is very important. Okay. Number 4, we've got fractions. We hate dealing with fractions, so we need to get rid of them. So we're going to multiply by the LCD. So remember, your LCD has to be big enough that 4, 3, and 2 can go into. So what we always do is start with the larger number. So if 4 is a multiple of the other two, then 4 would be my LCD. Now, if I choose 4, can 3 go into 4? No, it cannot. Can 2 go into 4? Yes, it can. But all of your numbers have to be able to be divisible by your LCD. So it's not 4. So I'm going to start listing multiples of 4. So the next multiple would be 8. Well, 4 goes into 8. 3 does not go into 8. And 2 goes into 8 evenly. But all of them have to work, so I can't use 8. So the next multiple would be 12. 4 goes into 12 3 times. 3 goes into 12 4 times. 2 goes into 12 6 times. So my LCD is going to be 12. So I'm going to multiply everybody by 12. And I'm going to show all my steps here because I don't want to lose anybody. Okay. So everybody is going to get multiplied by 12, even if you don't have a fraction. So 12 times 1/4 x plus 12 times 2/3 times x plus 3 is, I need to move this over. Actually, hang on. I'm going to pause this real quick and rewrite this. Okay, just needed to spread this out a little bit. All right, so notice that I've multiplied every term by 12, even the x. Okay, so a variable, if it was just a number like 5, you would still have to multiply that by, okay, you'd still have to multiply it by the LCD. Now, if we've done this right, our denominator is going to get, we're going to lose it. So 4 goes into 12 3 times. Perfect. Now here I'm just going to multiply the 12 times the 2/3. 3 goes into 12 4 times. This is just going to be 12 times x, so it's just 12x. 2 goes into 12 6 times. Okay, so let me, again, I'm just being very thorough. So now we're going to have 3 times 1x plus 4 times 2 times x plus 3. This is just going to be 12 times x. I'm just going to, again, I'm just going to rewrite. And I know I am being very thorough here because I don't want to lose anybody. And then 6 times 1. Okay, now we're going to clean all this stuff up. So 13 times x is just 13x plus here, I'm just going to multiply 4 times 2. So that gives me 8 times the x plus 3. And I don't want to do too much at one time because when I do that, that's when things are going to go wrong. 12 times x is just 12x minus 6 times 1 is just 6. Okay, we're not through cleaning stuff up. Now we're going to distribute. So this is 8x plus 24 Okay, now we clean up each side. 13x plus 8x. Wait, where did I get 13 from? That should just be a 3. Okay, 3x plus 8x is 11x plus 24 is less than 12x minus 6. Okay, and then we can, if you want, this is where it's your choice. I'm going to go ahead and move the 11 over. So I'm going to subtract an 11x from both sides. So that's going to leave me on the right side with an x. Then add the 6, which gives me 30 is less than or equal to x. But I don't like that, so I'm going to rewrite it. Okay. Now you can put this on a number line. It's an equal to, and it's less than, so it's going to be a bracket that goes towards the left. So my set notation is the set of all x such that x is less than or equal to 30. And then my interval notation is going to go from negative infinity to 30. So remember, your infinities have the parenthesis. In this case, the 30 has the equal to, so it has the bracket. Now, I know I drug this problem out and I wanted to show every step because I know people have problems whenever they're multiplying through by the LCD. It can get very confusing. Okay. All right, let's look at these last two or these next two real quick. So we're going to clean this up by distributing. So 3x minus 9 plus 17 is less than 2x plus 8 plus x. So we're going to clean up each side. So 3x plus 8 is less than or equal to 3x plus 8. Okay, so if I were to subtract 3x from both sides, then that would leave me with 8 is less than or equal to 8. Now notice how we lost the variable, but is this a true statement? Is 8 less than or equal to 8? Well, 8 is not less than 8, but it is equal to 8. That's a true statement. Okay, so remember when we talked about our equations, we had a conditional equation, then we had an identity, and then we had the no solution, the contradiction. Well, this would be an identity because 8 does equal 8. And if that's the case, then that means we have an infinite solution. So an infinite solution means you have all real numbers. So set notation, it's a set of all x such that x is any real number. And if it's any real number, then my interval notation is just going to be from negative infinity to infinity. Okay, that's it. So those same three cases hold for inequalities. All right. Let's see. Let me separate this. Okay, so here's number 6. Now, we have fractions. Okay, we don't like to deal with fractions. So I have a 4 and a 2. So that means my LCD in this case is going to be a 4 because 4 is a multiple of 2. All right, so again, I'm just going to show every step. So 4 times x is less than 4 times, 4 times this 2x plus 1 over 4 plus 4 times, man, I'm barely going to squeeze this in, 4 times x over 2. Okay, so this is just a 4x is greater than, these 4's get knocked out, so we're just left with 2x plus 1 plus 2 goes into 4 2 times, so that's a 2x. So we get 4x is less than, greater than 4x plus 1. So whenever I move my variables, I subtract a 4x from both sides. We get 0 is greater than 1. Now, that is not true. This is a contradiction. Since I lost my variable and I have a contradiction, then that means I have a no solution. There's nothing for me to graph, so I have a no solution. Okay? All right. Now, let's look at the next part. So the second page. And this is where we have, so we just solved linear inequalities. Now we're going to look at compound inequalities. Okay, so what we're going to do is we're going to solve these inequalities, and then we're going to combine them as according to whatever they tell us, if it's a and or an or. So let me remind you, the intersection is what is common from both sets, and we use the compound word and. The union is where you want everything from both sets, and we use the compound word or. Okay. All right. So we're going to solve these real quick. So this is x is greater than 5. This is 2x is less than 8. So x is less than 4. All right. So I'm going to put this on a number line, and I'm going to put them in order. Here's 4, and then here's 5. Okay. So x is greater than 5. So we're going this direction. X is less than 4. We're going in this direction. Okay. Now, we have the compound word or, which means we want everything. So I want everything from both sets. So my answer is exactly what I just drew. This is 5. Okay. So this part, we have 2 pieces for our interval notation. Okay. Well, actually, we have to do our set notation first. So this is going to be the set of all x such that this is going to be that x is less than 4 or x is greater than 5. Okay, so notice how I just took these 2 inequalities and I kept the word or. Now my interval notation, I have 2 pieces. I have this piece and I have that piece. So my interval notation is going to be negative infinity to 4. And then I also have this other piece that starts at 5 and goes to infinity. Okay, well, remember that our symbol for intersection is this thing that looks like an N, and the symbol for union looks like a U. So since I have a union, I'm going to use my union notation. And this is my solution. Okay. All right. Number 8, we're going to distribute. 6x minus 12 is less than 10x. And when I solve this side, that's just going to give me x is less than 2. Okay, well, I'm going to move the 6x to the other side. So that's a 4x. Divide both sides by 4. So we get that negative 3 is less than or equal to x. I don't like that, so I'm going to flip this around and say x is greater than negative 3. Okay, so I'm going to put this on a number line. Here's negative 3. and here's 2. Now, x is greater than or equal to -3 is going to go this way. Okay. X is less than 2 is going to go that way. Now, we have the compound word and, which means I want what is common. And what is common, where they both exist, is in between that region. So it's everything from -3 to 2. Okay, sorry. I had to pause real quick, and now I can't remember what the last thing I said was. Okay, so here are our the 2 graphs. So we want where they are common, and so they're going to be common in between -3 and 2. So our set notation is a set of all x such that, well, it has to exist everywhere in between -3 and 2. So -3 does include, we have a bracket. At 2, it does not, so that's just a parentheses. I mean, it's going to be strictly a less than. Okay. All right, then our interval notation, we take exactly from what we see. So we know we're going to start at -3. It's going to go all the way to 2. -3, we have a bracket, and at 2 is a parentheses. And so here we go. That's our answer. Okay. All right. Now, these next two, 9 and 10, notice how they're the same. The only difference is this is an or and this is an and. All right. So I'm going to save you some time here, because in all reality, at this point on a test, what I would actually end up doing, what I hope to do, is to include the problems where you wouldn't have to solve an inequality. Or if you do, it would be something very simple like, this 2x is greater than 10, a 1 or 2 step involvement. Nothing that's really tricky like this. So let me just go ahead and jump to what these answers are going to be. This one is going to give you x is greater than -2. This one is going to be that x is greater than or equal to -3. And then these, since these are the same, I'm just going to rewrite my 2 answers over here. Okay, x is greater than -2, and then x is greater than or equal to -3. All right, now the or. Again, guys, remember, I'm just saving you the steps in having to solve this. So that's why I just immediately gave you the answers. Okay, so I'm going to put this on a number line and put them in order. So we have the -3 first and then the -2. I want to do the same thing over here, -3 and -2. Okay, so x is greater than -2. So that's a parenthesis that opens towards the right. X is greater than or equal to -3. That's a bracket that opens towards the right. So I'm just going to repeat this over here. Okay, now remember, the or is everything. I want it all. The and is only what's common. Okay, so here we go. So my answer on a number line, if I want it all, here's the -2, and I'm going to erase this in just a second. So here's -2. I want this. Okay. Now I also want this, which is a bracket that starts at -3, and I want it all. which means notice how it covers up the x is greater than -2. Okay, so this is my solution for the or. So my set notation, let's see, let me see if I can squeeze this in over here, is a set of all x such that, well, in this case, it's going to be x is greater than or equal to -3. Then my interval notation would be from -3 to +infinity. Okay, so that's this answer. All right, now for this one, I only want what is common. And that, notice that they're not common on the left side. Only one exists, but on the right side, they both exist. Okay, so that means for the and, which is what is common, that's the intersection. The and is only going to start, it's going to start at -2 with a parenthesis, and it's going to go to the right. Okay, so now my set notation is a set of all x such that, in this case, we're going to choose that x is greater than -2. Okay, and then my interval notation would be from -2 with a parenthesis all the way to infinity. Okay, we just put this -2 up there. Actually, let me just raise this up a little bit so you can still see it. Okay, there, that's it. All right, now the next part, when we have what's called a three-part inequality, I always see people trying to split this up and then they try to put their answer back together. So in other words, when I say they split it up, they'll solve that and then they solve that and then they don't know what to do with their answer. Do not split this up. Okay, so a couple of things that I want to make sure that you do is, number one, when you have a three-part inequality, let's see, how am I going to do this? I don't have much room to write. Let me squeeze this in down here. Let me just write note. Okay, the first thing you want to do is smaller number. You want to check, do you have the smaller number on the left and the larger number on the right? Okay, that's what you definitely want to look for. Okay, and then your inequality, you always, for your three-part inequality, you always want the less than or the less than or equal to. Okay, you don't want to do that. And then probably the big one is, whatever you do, do not split apart. Do not split apart. Do not split apart. Okay. Sorry, I didn't realize I was off. Okay. Now, number 11. So I'm going to check. Smaller number on the left, larger number on the right. We have less thans, so we're good. Okay, now we're going to solve this, and I am going to show my steps. We're going to solve this just like we normally would. Since I want to solve for x, first thing I need to get rid of is that +3. So I'm going to add 3 everywhere. Okay, so now we have a 2x in the middle. And then we have our inequalities. So this is an 8 and this is a 2. Okay. Now the next step is that we're going to divide by 2. So I'm dividing by a positive, so I'm good. I'm not going to have to worry about flipping anything around. So this is going to give me 1 is less than x is less than 4. Okay. And so for set notation, you would say the set of all x such that, and then you repeat this. You say what that is. And then interval notation means it's going to go from 1 to 4, bracket at 1, parenthesis at 4. Okay, now here I honestly can't remember how Alex is going to want you to leave your answer. Okay, but just be careful. All right, now number 12, I have a fraction. I can do this one of two ways. I can get rid of the 1 first. Maybe we should do that. That would be the easier way. So we're going to subtract 1. Oh, first, smaller number on the left, larger number on the right, and we do have less thans. Okay, so we're going to subtract a 1 from both sides. So we have 6 is less than, I'm going to leave some space. Then we have the 3/5 x is less than or equal to 7. Oops, let me leave some space over here too. Okay, now I have this 3/5 times x. So I have, the way that I get rid of this is that I multiply by the reciprocal. And I'm going to do this everywhere. Okay, so 3 goes into 6 2 times. So 5 times 2 is 10. Is less than, well, these guys are going to knock each other out. They reduce. So there's your x, is less than or equal to. Now here I can't reduce anything, so I'm just going to put the 7 over 1, and that's going to give me 35 over 3. Now, if you're wondering, do I still have the smaller number on the left, the larger number on the right? Well, 3 goes into 35 10 times, and you have 5 left over. Okay, so we're good. Sorry, it goes in 11 times, and you have 2 left over. So 10 and then 11 and something. So, yep, we're good. So our set notation is a set of all x such that, and then we repeat this statement. And so our interval notation is going to be parenthesis at 10 all the way to 35 sevenths with a bracket. Okay. And then we have this last one. Now, this is going to be a tricky one. So we're going to do the same thing. Now, first, notice smaller number on the left, larger number on the right. -3 is smaller than -1. We have less than, so we're good. So we're going to subtract 1 everywhere. All right. So now we have -4 is less than -4y is less than or equal to -2. Okay, now, again, going back to what I said earlier, do not, at this point, do not divide everything by -4. When you divide by a negative, that is when you have to change your inequality. So here I'm going to divide by a -4. So I flip my inequality. Divide by a -4. I flip my inequality. Okay, so this gives us 1 is greater than y is greater than or equal to 1/2. Now I have a problem because my smaller number is not on the left and I have greater than symbol. So we're just going to flip this around. 1/2 is less than y is less than 1. And I'm running out of room, so let me squeeze this up here. So our set notation is going to be the set of all y, because that's our variable, such that 1/2 is less than or equal to y is less than 1. And then interval notation goes from 1/2 to 1. 1/2 has a bracket, and the 1 has a parentheses. And there's our answer for that one. I ran out of room. Okay. All right, last problem. And it's a word problem, but this one is not bad. It says one cell phone service charges a flat rate of $35 a month plus 1 cent per text. Another company offers a flat rate fee, a monthly fee of $50 with unlimited texting. How many texts would you need to send for the first company to charge you more per month than the second company? All right, so the first thing is I notice we have two unknowns. So we're going to have company 1 and then company 2. Now, they told us what they're looking for. And oh, here it is. Okay, so they told us what they were looking for. It said, how many texts would you need for the first company to charge you more than the second company? So that means company 1 has to be more than company 2. Okay, so now we're going to identify our unknowns. It said one cell phone charges a flat rate of $35 a month plus 1 cent per text. Okay, that's company 1. So 35 plus 1 cent is 0.01 times however many texts you send. Okay, per text. The second company, another one, charges a flat fee of $50 with unlimited texting. So they're not going to charge me for texting. They're just going to charge me $50. Okay, so now we're going to plug this in. So company 1 is 35 plus 0.1x is greater than 50. So I'm going to subtract 35 from both sides. That gives us 15. We're going to divide by 0.1. So we get that x is greater than 1500. Now, what did we just find? Well, we just found, because it says how many texts. Okay, so that means you would need to send more than 1,500 texts per month. Per month. And on some word problems, it's not enough to just solve, but you might also have to give a verbal explanation. Okay. All right. So that's it for section 1.5. Let me know if you have any questions.